Hey guys, so here's the do now that I've listed in your lesson plan. I want you to try to do it yourself without watching me first. So you might want to pause this video, have a go yourself, and then watch what I do later to see if you got it right, or if you perhaps if you made any mistakes, you can fix them up. So pause now. I'm going to do it. Okay, so we're all set up. We're dividing this polynomial by this here. Remember, you need to take the first term and divide it by the first term over here. So x cubed divided by x is x squared. Now you're taking whatever's up here and you're timesing it by each of these. So x squared times x squared times 2. Right, and now we're subtracting. So we're subtracting this from that. So x cubed minus x cubed is 0. Minus 2x squared minus 2x squared is minus 4x squared. And we bring the next term down. So now we sort of forget about what's going on up here. This is what we're focusing on, and we're starting from the first step again. So minus 4x squared divided by x. We're taking this term and timesing it by both of those. There we go, and now we're subtracting. So that minus that is going to give us 0. That plus that is going to give us 3x. And we bring that last term down. Oops, plus 6. Alright, so this is what we're focusing on now, not what's going on up here. So the first term divided by x. Now we're taking this here and timesing it by both of these, so 3 times x and 3 times 2, and we're up to our subtraction stage or step. 3x minus 3x is 0, 6 minus 6 is 0. So we can see now that the bit up the top, this bit is our answer. So when we divide this polynomial by that there, this is our answer, and we have 0 remainder. Now if there's 0 remainder, that means that this is a factor of this polynomial. Alright, so let's move on to 6c, which we'll be doing this lesson. Okay, so in 6b we're learning how to do long division of polynomials, and we just did that do now as well, and we could see that there was, what we divided by was a factor. It is a bit of a process to go through and divide to see what the remainder is or if it's a factor, which can be a little bit annoying. We don't want to spend a whole lot of time doing that. So there's actually a much quicker way to work out what the remainder is going to be, or to work out if another polynomial is actually a factor. So it's this remainder and factor theorem that I've got written down here. So exactly as I explained before, we can find out if we have a factor or what the remainder will be without dividing. If we divide a polynomial, and I marked up here, I should put that there, so the polynomial is called f of x, by this other polynomial here, the remainder will be equal to f of a. So that means we're going to take that polynomial rule, substitute this value of a into there instead of x, and whatever the answer is, that's what our remainder is going to be. So let's try that with these 3 examples here. So here's our f of x, here's our polynomial, and we want to divide by x minus 3. Now I'm not substituting minus 3 into there, I need to actually change the rule around. So if you notice up here, this one we're supposed to be dividing by x minus a. We're not substituting in minus a, we're substituting in a. So we actually need to change that sign around. So, I'll use p. I'm going to be substituting in 3. I need to flip that sign around. So wherever there was an x, I'm now going to be putting in a 3, and we should be able to work out what the remainder is from that. So I'll substitute those 3's in. There's our rule. Cool, so I'll substitute those 3's in. All we need to do is work this out now. Okay, 27 minus 27 is 0, minus 18 plus 8 is minus 10. There we go. So if we decided to divide this polynomial by that, our remainder is minus 10. You see how we didn't have to go through the whole process of long division? It's way quicker. Let's try again with this one. Now, instead of substituting in plus 2, again, we need to make sure we're changing that sign around. So we're not going to do plus 2 in here. It's going to change to minus 2. And we're doing the same thing. So let's substitute that minus 2 in where x is for our rule. We've substituted them in. Let's work it out. Okay, so we've got minus 20 is that bit, plus 20, so we can see that our remainder is 0. Now hopefully remember from the other class when we did 6b, but also the do now, that if your remainder is 0, x minus a is a factor. So we could say that x plus 2 is a factor of f of x. There we go. Okay, so the last one that we're going to try this theorem on is here. This might be a little bit harder because we can see that it's 2x plus 1, where all these ones, they didn't have a coefficient on x, or the coefficient was 1. Now the coefficient is 2. Now the same when we're trying to find the x-intercept, when we've factorized, for example, a quadratic expression, we need to make all this equal 0, and that's what we're actually going to be substituting in. So 2x plus 1 equals 0. We want to solve for x here. So x is going to be minus 1/2. That's what we're going to be putting in to this spot here, or this spot here. So we want p of minus 1/2. I'm only using p because polynomial starts with p. Exact same steps as before. There we go. So this might be a little bit more difficult because now we've involved fractions, but that's okay. Hopefully we can still work them out. Okay, so let's just put these couple of fractions and numbers together. If I'm adding these fractions, I need to make sure the denominators are the same. So I'm going to change this one so it has a denominator of 8. So I'm going to times that 4 by 2, but I also have to times the top by 2 as well. So this is going to become minus 6 on 8. We can just put these together. Got minus 7/8 after putting those two fractions together. Now we should put these numbers together as well. So again, we need to make sure the denominators are the same. So I might just work with 11 first. So if we want to have 8 as a denominator, remember this is just 11 on 1. So we need to times that by 8, which means we have to times that by 8 as well. So we're going to have 107 on 8 plus 88 on 8. So that'll end up giving us 81 on 8. And that's our remainder. Okay, so for this example here, we've been asked to find the linear factors of this polynomial here. Now all that's saying is, I'm gonna change it. Instead of find the linear factors of these words here, it's just factorising. So we're using long division to factorise this polynomial here. Now in order to factorise, we need to end up having things that the remainder is 0. So with this question, and to find factors, it's a little bit annoying because you have to do a little bit of trial and error. So firstly, I want to see if, let's just say, I want to see if x plus 1 is a factor. Now, the way I find that out is I need to use my factor or remainder theorem. So, instead of plus 1, I need to put in minus 1. Now, if this ends up coming at an answer of 0, that means that x plus 1 is a factor. Let's see what happens. Now sometimes you're going to already be able to see whether it's going to be a factor or not. So this will end up being we can already see that this is going to end up being a positive number. Okay, so we've got minus 4 here. If you add 6, that's 2. If you add 8, that's 10. So the remainder would be 10, therefore it's not a factor. So we could say that doesn't equal 0, therefore x plus 1 is not a factor. Alright, so that trial didn't work. We need to try again. Now I just want to bring your attention to the other question that we were doing, so that we're looking at before. You see what we're trying to factorize here? That's actually the same as this question that we were doing. But we can't see them both. Yeah, you can. See how they're the same thing? Before, we ended up working out that x plus 2 was a factor. So we can use that one to long divide to try and find out what the other factors are. Alright, so if your x plus 2 was a factor, that's what we're dividing by, and we're dividing this polynomial here. Now if we divide that by that, it should give us the other factor. So let's do that. Let's go through that process. We did it in the do now, we did it the other class as well. So hopefully we're okay at this now. It can be a bit difficult, but I'm just going to do this one for you right now. So this is what we're focusing on now. There we go. So we can see, sorry, the camera went a bit funny then. We can see that the remainder ended up being 0, which is good, which is what we want. So it shows that that definitely was a factor. But we now have, well, initially we had this. Now that we've factorized, we've worked out that if we times that by that, it's actually the same as that. So if we expanded this one out to check that we were right, it should be that answer. If you expand this one out and it doesn't come back as that, you're wrong. You have made some kind of mistake in your long division. You might have to go back and look. Now, remember, we were asked to factorize here. We have now one factor and another factor. Now, when it says linear factors, that means we're looking for things like this. This is linear because x is to the power of 1. This one here, we have an x to the power of 2. So this is actually a quadratic factor, a linear factor and a quadratic factor. We were asked for 3 linear factors. Now, hopefully you guys can remember from our quadratics unit or topic, we can actually factorize this and it's going to turn into 2 more linear factors. So we learned how to do this kind of stuff. All you need to do is factorize this quadratic and you're going to have 2 more linear factors, which means that we're going to end up having all linear factors. So I want you guys to just factorize this bit and then we're going to end up being done because we're going to have all those factors. So I'm going to write up here instead. All I want to do is factorize that. Alright, so the factors of 4 that add up to minus 5, that would be negative 4 and negative 1. There we go. So we have factorized it. So now we don't want to forget about our other factor, which is x plus 2, and we change this into those 2 there. And we're finished. We've found our 3 linear factors. So that's how you factorize just your normal polynomial function. These ones here are a little bit different. So you might remember difference of 2 squares and the rule that goes along with that. We're going to be working with powers that are higher than 2 now. So mainly 3 at the moment, to the power of 3 at the moment, which is cubic. This might look a little bit similar to difference of 2 squares, except instead of squared, it's cubed. Hence, difference of 2 cubes. Same with this one over here. Instead of difference, it's a sum. That's why you're going to see a plus there. Now, we're going to try to use these rules that we've been given to factorize these expressions down here, or these polynomials down here. So, let's try A first. Now, I just want to look at this rule here. It has a minus in the middle. If there's a minus, it can't be the sum of 2 cubes. It's got to be the difference of 2 cubes. Now, with the difference of 2 cubes, we have something cubed minus something else cubed. We've got something cubed here. 64, that doesn't have it to the power of 3 up there, does it? But I think we can actually change that, can't we, to help us out? So this here is actually equal to x to the power of 3 minus, now I want you guys to think, what to the power of 3 gives you 64? 4 times 4 is 16, times 4 is 64. So that means that we're going to use 4 to the power of 3. Now it's going to be way easier for us to use this rule now, isn't it? All we need to do is just put our x and our a, this is going to be our a value, into this rule. So let's do that. So it's going to be x minus 4. I'm just looking straight at this rule here. X squared plus 4x plus 4 squared, which is 16. There we go. We've factorised that one using the rule that we were given. So let's move over to the next one. And this is going to be the last example that I give you guys. So this one, we can see that there's a plus, which means we're going to need to use the sum of 2 cubes. Now that factorisation rule here, it looks super similar. The only differences you're going to see are the signs that are here. So we're pretty much going through the same process. Now I want to look at these two terms here. Now this is showing that there's just one thing to the power of 3. We have that one thing to the power of 3, but there's also an 8 out the front. That's kind of putting a little bit of a spanner in the works. Same with the 27 out here. We just need one thing to the power of 3. So I want to change both of these so it's only one thing. So I want something to the power of 3 plus something else to the power of 3. Right, now hopefully we already know that 2 to the power of 3 is 8. So if we put a 2 in there, that's going to give us the 8, but we also need x to the power of 3. There we go. So with our index laws, which we've already gone over, I believe, this to the power of 3 applies to that, and the to the power of 3 applies to that as well. So that's going to end up giving us that. So that's how that one works. With this one over here, 3 to the power of 3 is 27. There we go. So all we're doing now is substituting these into the correct spots of this rule. Oops. Okay, so I've substituted all those things in. Now I think we can apply the squareds and put these two together and apply the squared as well. And there we go. That should be it. So have a look at the lesson plan. It should tell you the questions that I want you to have a go at. Thanks a lot, guys. See ya.